record this one. Okay. So first of all, before any analysis, we need to understand what is going to be our study period. So a study period means that you got one start date and one end date to that project. And during that time, you need to understand what would be the cost, what would be the earnings and everything, so you can calculate how much is going to be the benefit or loss of doing this project. So the study periods can be different from a project to another project. Maybe you have a project that's, for example, you getting all the raw materials, you process the raw materials, and then you make it, for example, in a construction material. Then you use it in a building, you build a building, and then you own the building and rent it to the tenants. And then after the life cycle is finished, you're also responsible for demolition and recycling and etc. So this is going to be the whole life cycle, but most of the time it's not going to be like that. The project that you're working, maybe it's just part of that life cycle chain. So maybe you're just a company that construct the building. So you just get the materials. So you want to have different project in construction of the building. So you don't care about like what's going to happen before that. So the raw materials and the construction material is going to just be an input cost for you. And also, when the construction is finished, maybe you just want to sell it and you take your profit, so you don't. So what happens after that to this building? You may have some insurance for it, but whatever happens, it's not your concern in terms of demolition, maintenance, etc. So it depends at which stage is your start date of the project and which stage is your end date of the project. So the study period is a time during which the effects of a decision are of interest to the decision maker. So again, if you just construct a building and sell it, so any maintenance or any demolition, etc., after life cycle of the building is not your concern anymore, so it's not part of your study period. In that case, your study period is going to be from the design and planning until the construction is done and you're going to sell the properties. And when all the units, for example, are sold, then the project is going to be finished. And this is going to be your study period. But if you're going to rent that property, for example, you're building a shopping center, after finishing it, you just want to rent it, then this is different and your study period can be much longer. And it can take up to 50 years, 60 years. It depends on the condition of the shopping center. And then perhaps you need to study the whole life cycle of what's going to happen to this shopping center, not just after the construction is finished, but also the cost of the maintenance, any major work that's required after a few years, and some other things, any fluctuation in the rents that you can collect, and those kind of things part of your study period. The other thing about the study period, when you're comparing different projects, so for example, let's say that you want to build a shopping center, or you want to build a high-rise apartments, or you want to build a school. So if you're looking at the different alternatives, so they should be studied at the same study period. And that gives you a good indication of about the benefits of that project or compared to the others. There can be some exceptions. For example, maybe the life cycle of the building is different. In those scenarios, you can do some adjustments, but it would be most comparable if the study period would be the same. The other thing that you need to consider that the life of a product, for example, a building under analysis determines the length of the study period. For example, if you're going to use that building as like a rental income, so the life cycle of that building, it's determining your study periods. For example, some buildings has 30 years life. Some buildings may have up to 50 or 60 years life, but depends on the, so you cannot say that, I'm going to make this shopping center and my study period is going to be 100 years. Perhaps it's going to be too much in terms of the life cycle, because at some stage the building, the maintenance is going to, the cost is going to be too high for you to have any economic benefit in order to keep it going. So it's better to demolish it and make a new shopping center, uh, in terms of the economic value of it. Sometimes you want to use, for example, an equipment, and you decide that, I want to compare equipment one compared to equipment two, or equipment A compared to equipment B. And my study period is 50 years. I want this equipment to work for 50 years, maybe like his HVAC system, or something that you want to use in your building. And then you just to your procurement plan, and the different bidding and different initial cost, etc. But it's not about the initial cost. When you study during the period that your study period, then you realize that the other factor is also equally important. So the other factor is about the service life of that equipment. So for example, equipment A has got a 50 years, 60 years of service life. So which means that this 60 years is greater than your study period's 50 years. So presumably nothing gonna happen to it during these 50 years. So it's just going to be in one initial cost, maybe some maintenance, uh, maybe it has some warranties for a few years, etc. But for example, when you look at the equipment B, the service life is only 30 years, but you want this equipment to work, for example, in your building for 50 years, which means that after 30 years, you need to replace that. So you got some replacement costs, can be even higher than your initial cost. So maybe your cost is going to be doubled. And so that can be a problem. And although that the initial cost can be lower for option B, because you're going to double the costs during the study period and life cycle of the project, then when you compare it with equipment A, maybe equipment A is going to be more economical. And also the other thing is the residual value of equipment. So after your study period is finished, can you resell that equipment? That's another thing that you can put it as a kind of final earning after the project finish, and just do it in your calculation in order to compare product A versus product B. Okay, you may ask how to decide the study period. There are a couple of things that you need to have a look. First of all is the economic lifespan. So the economic life refers to the amount of time an element is in service before its replacement is more advantageous economically than the continued maintenance that will be required to keep it in service. An example of that would be having a car. So let's say that you have a car for over 20 years or 15 years. And after that, it depends on your pattern of consumption. The car is getting old, and you realize that you're paying a lot for the maintenance. Maybe you're paying like 2,000, 3,000 per year just for maintaining that car. And you realize that maybe it's a good time now to just buy a new car. So this is one thing, for example, that decides the study period for that car can be 10 years or 15 years based on the level that you use this car. The same thing for the building. So different building has different lifespan based on the environment that they are sitting, and also based on the type of the material that has been used in those buildings, and also the level of use of those buildings, if it's a residential, commercial, etc. The other thing that you need to have is just a physical lifespan. Maybe you have consumables that is going to be finished soon. So that it means that you don't have it anymore and you need to buy a new one. For example, that can be like a tires of the car. After a period of time, it's going to wear off and you cannot use it anymore. So the physical lifespan is finished. And sometimes it's end of analysis period because of selling or demolition. So as I mentioned, you just want to construct the building, and after you sell it, then you don't have any much concern about that building because you already sold it. So that is going to be the end of your study period, no matter how much is going to be lifespan of that building or what is the procedure for demolition, etc. But one thing that you need to take in account in your calculation is the remaining value. So remaining value, it means that after your study period is finished, can you resell the product to others, or can you, for example, recycle it and earn some money, etc. And for different scenarios, you may end up like not having any remaining value, or even remaining value can be negative. So you need to pay someone for demolition and transferring the debris to somewhere else or recycle it. But sometimes you may have the building that you're renting it out, but you just want to do it for 20 years, and after 20 years you decide to sell it to another developer, or you just want to sell it to public after 20 years. So this is going to be the remaining value. Definitely it's going to be lower than the initial value of the building after 20 years, but it's something that you need to consider as the earning at the end of the study period when you're comparing different projects. So you can use this PDF to get better understanding of different service lives in North American buildings. And also you can find more references when you search online. So this is one of our references. As you can see, they are in different literature. They put different lifespan for different type of buildings, whether it's commercial, residential, institutional, etc., and different location, UK, Malaysia, and US. And as you can see, it can be from 20 years to over 100 years based on the type of the building. And each of those may have different capital cost and also running costs in terms of the maintenance, etc., as a percentage of life cycle costs. So you can find all those information online and in the literature. And the other thing that you need to understand is about the discount rate. So what is discount rate? I'm going to introduce it to you in the next slide. So let's see this video. Let me know if you cannot hear the sound. I haven't played it yet, but just hang on a second. Yep, here we are. So is everyone cannot hear the sound? So let me double check. I'm going to do it again. So let's see if it works.
In this video, we're going to look at why you discount the future when doing cost-benefit analysis. Would you rather receive $100 today or $100 in 10 years? I'll tell you what you want before you answer. And it's going to be right. You would want $100 today because you can do stuff with it now. You could lend that $100 to the bank who will pay you interest for it, and after 10 years you would just have more than $100. Or you could buy a violin, a crappy violin, learn to play, and in 10 years make some sort of profession out of it, or just simply have gained that enjoyment from it. An enjoyment that you would have had to wait for if you had received $100 in 10 years. Also, you could be dead in the future. You know that dog you had when you were a kid and your parents said it went on doggy vacation? It's not on vacation. It's dead. Every day into the future is another day we are uncertain we will be alive, so we prefer to have things in the present. There is an opportunity to do things with money, goods, and services today, as well as an inherent risk that we might not be able to enjoy them in the future. Whether you're going to buy something or save the money, there's a greater value in having something in the present than having it in the future. It's not that it physically has less value. This isn't about inflation or anything like that. And for our purposes here, we're using the real value and assuming that $100 today buys the same amount of stuff as $100 in 10 years. It's just that having money, goods, or services earlier lets you do things with it that may increase its value to you. So when comparing costs and benefits across different time periods, we discount the future. We ask, what's the $100 gained in 10 years worth today? What is the present value of $100 from 10 years from now? But let's first calculate what $100 from today would be in 10 years. Okay, what's the future value of $100 in 10 years? We'll use the bank's interest rate to represent that, because that's a good basis for what we would be doing with the money, just putting it in a bank. Let's assume the money grows by 5% a year with compounding interest. We would multiply $100 by 1.05 to grow it by 5%. 1 to account for the money we already had that we'll get back, and 0.05 to account for the interest we'll earn. Okay? Then we take that $105 and multiply it by 1.05 again for the next year. Then we do that 8 more times. Or we could have just written it like this, taking the 1 plus the interest rate to the power of 10, since we're just multiplying it by the interest rate for 10 years. So $100 after 10 years of interest is $162.89. The future value of $100 from today in 10 years is $162.89. Back to that first hypothetical situation, this is how much we would expect to receive if we were to give up $100 today. We would want at least $162.89 in 10 years' time, because if we got $100 today, we could make it into that much by lending it out for 10 years. So if the question were, would you rather receive $100 today or $162.89 in 10 years, since these are basically equivalent, you should have no preference. To do it the other way, to determine the present value, we just divide by 1 plus the interest rate. So if we were to get $100 in 10 years, what is the present value of that $100? Take 100, divide by 1.05, 10 times, or 1.05 to the power of 10, and we get $61.39. The present value of $100 received 10 years from now is $61.39. This is the amount of money that if we put it into the bank for 10 years, it would become $100. So if you were asked, would you rather receive $61.39 today or $100 in 10 years? These are also basically equivalent and you should have no preference. This works for costs too. Would you rather pay $100 today or $100 in 10 years? Well, let's look. If we pay $100 today, we would be out $100. But what's the present value of $100 costs in 10 years? It's the same calculation. 100 divided by 1.05 to the power of 10 is $61.39. So what that means is we could put $61.39 in the bank today and it would grow to become $100 in 10 years. So paying in 10 years is easier. That is, if you plan for it by saving now. Otherwise, it's still a $100 cost. Remember, it's not that the costs and benefits are less in the future. Discounting the future is just a decision-making tool. We can use it to compare the costs and benefits of different projects to find out which gives the greater payoffs when considering this time preference of money and how each dollar is valued at different times. The discount rate you choose is very important in this process. There's no hard rule for which rate you might choose, but it should be based on what the best alternative use of these resources are. So if you're a private firm doing a financial analysis, you may simply use the market interest rate or some other investment very similar to what we've been doing. Or if you have money coming in from different sources with different interest rates for the same project, you would want to use a weighted average discount rate. So like if 30% of your money came in from the bank at 5% interest, but the other 70% came from investors that expect a 17% return, you would use a weighted average of the two interest rates. You would take 30% of your 5% interest rate and 70% of your 17% interest rate as your discount rate. So 3/10 of 5% is 1.5%, and 7/10 of 17% is 11.9%. Add them together and you get 13.4%. And this is the discount rate you will use for this project. If you're doing an economic analysis, you will look at the economic opportunity cost of capital. What is the next best alternative use of these public funds? The economic discount rate will be different from a financial rate. It's typically lower. This is partly because public entities, the government, have more patience than individuals. The planning horizon accounts for more than just the lifespan of a single individual's viewpoint. So that preference of consuming something in the present and that risk of personally not being able to experience something in the future isn't as important a factor from a societal point of view. So more weight can be put on the future and a lower discount rate can be used. Remember, with a higher discount rate, less weight is given to the future. With a lower discount rate, more weight is given to the future. A discount rate of 0 would imply that the future has the same weight as the present. So an individual setting up a conservation park with a fee would expect higher returns and discount the future more because he expects to enjoy the benefits as soon as he can. Whereas a government is more patient and discounts based on everyone's ability to enjoy. Secondly, governments are usually able to borrow money at lower interest rates than private citizens or firms, and there is less pressure to gain immediate benefits. In other words, the opportunity cost to public projects is lower, so public projects use lower discount rates. In situations where the market is very unstable or there is political unrest, you might have to use a higher discount rate. For example, if you're going to invest in a forestry project in a place where there's an insurgency and slash and burn farming nearby, you're going to want a bigger return from the forest to offset the fact that this whole thing might burn down before you can harvest it, or it might be appropriated by rebels and it's not yours anymore. If the bank or investors feel this is a risky investment, they will expect a higher return, and the discount rate must be higher to account for this. Contrasted to that, you'll accept a lower discount rate from a forest somewhere peaceful, and maybe with a big forest firefighting team. You'll use a smaller discount rate because you're more certain your investment will pay off. You'll apply a higher discount rate to the payoffs from a risky investment than from the sure thing. Later on in the course, we'll talk more about how we use discounting. For now, in the next video, we'll look at some of the limitations of discounting and other considerations with respect to the time horizon of the project.
Okay, as mentioned in this video, so we put the discount rate in order to get the present value of money, because we know that $100 that we get in 10 years time from now is not going to be equivalent to $100 that we owe now. So the formula to calculate the discount rate is pretty simple. So you just use the discount rate in the formula that is shown in the screen, and you got the period numbers. Normally it's the number of years. So for example, if your study period is 10 years, then you need to use that for each individual year. For example, year 1, year 2, year 3, etc., in order to calculate the discount rate. So factors that can affect discount rate is, first of all, the inflation is important, because when there is a higher inflation or higher expectation of inflation in the future, it means that the future value of money is going to be decreased. Because, for example, if you got $100 now, you make by, let's say, something. But for example, if the inflation is 5% or 10% or something like that, 10 years from now, then with $100, you may not be able to afford to the thing that you used to buy it for $100. The other thing is about the cash rate. So the cash rate and inflation are going to affecting each other's, but the cash rate is going to be unlike the inflation, which is it's not something certain. So it's based on the consumer behavior. The cash rate are set by central banks. So central banks puts the cash rate, and this cash rate is the interest that central bank is getting from the other institutional banks in order to lend them the money, and other banks, those banks are going to lend money to you, putting some interest on top of the cash rate and pay you that loan for that interest rate. So lower interest lower cash rate, it means that you may be able to get lower interest from the bank, and that is going to affect the discount rate. So it's going to reduce the discount rate because you expect that the future value of money is going to be higher than the other scenario, that the cash rate was much higher. And as I mentioned, it's also affecting the inflation. So if you put high cash rates, it's expected that inflation is going to be higher as well. Is the cash rate the same to risk-free rates? Yeah. The general term is the cash rate, but it's also different in different countries. They can also put it as the risk-free rate as well. So these are the different definitions, but the main concept are all the same. But as an investor, I just want to, if you consider only the inflation and cash rate, this means that the return that you're getting is going to be more or less the same as you just put your money in the bank. So you want get extra return for taking the risk of doing that project. So this is going to be added to those rates in order for you to get a discount rate that is going to be suitable for your project. And also, as mentioned in the video, in different environment and different condition, that extra return for taking the risk is going to be different. For the environment that you probably saying that a little bit of unrest or something happening that it can endanger your project, then it's going to be, you're expecting to have high return for getting that risk. But in the environment that you don't foresee any kind of major risk, then that extra return can be lower. The other way of calculating the discount rate is based on the comparable projects or what is normally used in that market or that country. So this is also giving you a guide. So after you calculated your preferred discount rate, you can compare it with the common discount rates in the market or in the country and see that how far you are below or above that, and you can adjust it. As I mentioned, there are many things that can affect the discount rate. So there is a bigger spread in terms of the discount rate that you can choose, but it's normally between 2% to 20%, which you can use based on the different type of the projects that you have. The other financial tool that you can use in order to compare different projects is a saving to investment ratio. So saving, it means that after this project is finished, how much money you can earn, so how much money you can save, those kind of things. So either earning or saving money compared to the initial investment. So let's say that you want to put some solar panels. And these solar panels on top of your house will cost you, let's say, $20,000. And you're saying that this solar panels is going to work for your house, and the lifespan of that is, let's say, is going to be 20 years. And you realize for the next 20 years, you're going to save $25,000 in terms of the energy bills. So your saving over life cycle of project is going to be 25 years, and your initial investment is 20 years. So which means that the saving is higher than the initial investment, so you can have some profit. So saving to investment ratio is higher than 1. But in the other scenario, if after lifespan of this panel is finished and you realize during that 20 years you can only save $15,000 because you don't consume electricity that much, then the savings is going to be lower than initial investment, and the SIR is going to be less than 1. So it means that it's not going to be any economic value in order to buy those solar panels. So an SIR greater than 1 means that the alternative is cost effective relative to the reference case. Sometimes you just want to compare different scenarios, and if the SIR is going to be higher than 1, this is going to be likely a good scenario compared to the reference case that's in this scenario that I mentioned, it's just doing nothing, so just pay for the grid electricity. It's in terms of the money that you save is going to be better if your SIR is less than 1. So the SIR is recommended for setting priorities among projects when the budget is insufficient to fund all cost-effective projects. So this is another tool for use for the project selection. And normally the projects are ranked in descending order of their SIR. So the higher SIR are more preferable. The other tool that you can compare different projects or different product is going to be net saving. So, and in that case, you compare the life cycle profitability of one project compared to the other, and you say that if I do this compared to the other project, that is going to be that amount of saving that I'm going to have. So this is another very simple things that regardless of this, all of us can do. But sometimes it's not just as simple as the example that I mentioned about the solar panels. There are many other things happening, especially for bigger projects and for companies, that is not just about the single item purchasing and paying for electricity. It's going to be lots of other things that affecting the amount of the money that you earn and the bills that you need to pay and heaps of other things. So in that case, we are looking at something that is called cash flow. So cash flow is the net amount of cash and cash equivalent being transferred into and out of a business during that period. So you calculate cash flow during your study period from the year 1 to the end of year X for the study period, and then you're going to discount it back into the net present value, which I'm going to discuss that after watching this video.
Cash flow refers to the movement of cash into or out of an account, a business, or an investment. When cash inflows exceed outflows, this is generally considered to be a sign of good financial health, both for individuals and companies. Ed makes his living running Ed's Carpets. For Ed, cash flow is essential to the survival of his business, as well as his personal finances. Having ample cash on hand ensures that Ed can pay his employees, his creditors, and himself on time, keeping the business afloat. The same goes for Ed. He needs enough cash in his personal bank account to pay for his house, his car, and other personal expenses. Whether we are talking about Ed or his business, there are generally 3 types of cash flows. 1. Operational cash flows refer to cash received or spent as a result of a company's business activities. For example, a business like Ed's Carpets brings in cash by selling carpets and sends cash out to pay employees and suppliers. Similarly, Ed pays himself a salary, providing cash flow to his personal account. Cash will flow out to pay for his expenses, such as food and housing. 2. Investment cash flows refer to cash received or spent through investing activities, basically the purchasing and selling of assets that will help grow the business, or in the case of Ed, assets that will help increase his net worth. 3. Financing cash flows refer to cash received through debt or paid out as debt repayments. For a company, issuing stock, paying down debt, and repurchasing shares would count as part of financing cash flows. For Ed, financing cash flows include any cash coming from loans or other types of debt, as well as payments going to pay down debts. If Ed's business comes up short on cash and is unable to pay its obligations, it will experience a cash flow crunch. To avoid insolvency, Ed will have to arrange some type of financing or bridge loan. A similar situation in Ed's personal accounts would also have disastrous effects that could lead to personal bankruptcy if the cash flow crunch persisted. For this reason, it is important that businesses and individuals manage their cash flow carefully and set aside emergency reserves to cushion any unexpected events.
The free cash flow means that the cash flow that you got from operation minus the capital expenditure. Sometimes you also have some capital expenditures from the start of the project or in the middle of the project that also you need to take into account when you're calculating the cash flow. Got one question here, Emiliano asking, can we calculate SIR example? I don't get your question. What do you mean, can we calculate an SIR? Do you want me to provide an example or can you elaborate more on your question? Okay. So while you're doing that, let's move on. In terms of the cash flow, we also want to discount it when you're comparing different projects at the present value. We want to discount cash flow. And let me break down this equation for you, the discounted cash flow. Let's assume that we don't have any discount rate. So the R, which is the discount rate, is going to be 0. So it means that your overall cash flow, the money that you can receive, is going to be the money that you receive in year 1, which is CF1, plus the money that you receive in year 2, and net cash flow, and the money that you receive in year 3 until completion of the study period. So this is the all money that each year you collect. So after paying your bills, etc., and paying your tax, these are the money that you're receiving. So this is going to be your free cash flow. Or if there's any capital expenditure, you also deduct that from that cash flow. So this is going to be your cash flow. And but you know that cash flow that you're earning 10 years from now is not going to be equal to the cash flow that you're earning next year. For this case, you need to put it the discount rate, and when you add the discount rate, so the cash flow in the future is going to be less than what you calculate now. And based on the discount rate, a higher discount rate means that the net present value of your cash flow or discounted cash flow will be lower if your discount rate is higher. And also it depends on the number of years. For example, if this project is going for 10 years, so and if the cash flow that you're earning in year 1 and year 10 is equal, but because it's 10 years from now, the discounted cash flow is going to be much less because you're putting the discount rate and also number of years into the equation, and the discounted cash flow from 10 years from now is going to be much less. So anyway, the way that you just do all your earnings minus your expenditures and costs and everything, and you get cash flow for each year, and you just discount that for year 1, you do it for year 2, and for all the study period, and you just sum it up, and then you can get your discounted cash flow. So here you can see that 1, 2, 3, n is going to be number of years, but can be any other study period. Normally, it's been used of the way that the discounted cash flow is been calculated is based on the number of years, but can be any other study period. Depends on if you want to apply that discount rate for 1 year, then it's going to be 1 year. If you want to apply that discount rate for each 6 months, and you're, for example, you're looking at your cash flow each 6 months, then it's going to be each 6 months. But generally it's going to be based on the number of years. Okay, so net present value. So after calculating your discounted cash flow, then you're looking at the value that you're investing now. So let's say you calculate for 10 years and you realize that your discounted cash flow during these 10 years based on the money that you can collect as you're earning minus your cost, and then your discounted is going to be, let's say, $55,000. And for that particular project, at the moment, you're just only spending 50,000 for the investment. So which means that the net present value is going to be 5,000. All the time, you want to have a positive net present value for your project, because otherwise your project is a loss. So the higher the NPV is going to be better for you. It means that the return of that project is higher. So when you select the project, you're looking at the project with higher net present value. So the positive net present value, it means that the project earning generated by a project or investment exceeds the anticipated cost, or in the other term, the project is going to be profitable. And negative net present value, it means that the anticipated cost generated by project or investment exceeds the project earning, or you're incurring a loss. Okay, so let's do an activity together to see that how we calculate the discounted cash flow and the present value. So let's say that we got $50 million that we are investing in a sustainable equipment for a project that is expected to generate $15 million per year for 4 years. So your study period is going to be 4 years. And each year you're earning your cash flow is going to be $50 million. At the end of the project, the equipment that was used can be sold for $12 million. So in year 4, on top of the $50 million that you're receiving, you also, when the project finish, you sell the equipment and you get $12 million. So you bought it 5 years ago for $50 million. Now you can resell it for $12 million. And for this particular project, we got a discount rate of 12%. Let's assume that you did done all the calculation, etc., and you compare with the current market discount rate, and you realize that 12% is going to be good for this project. And the thing that you want to do now is just to calculate the discounted cash flow and net present value to realize that whether this project is going to be profitable or not. Okay, so this is the equation that you use. So you got 4 years, so you got 4 of different discounted cash flow from year 1, year 2, year 3, and year 4. And here is your 12% discount rate. As you can see, 1 plus 0.12. And these are the number of the years, 1, 2, 3, and 4. As you can see, in the 4th year, you got $50 million as the cash flow plus the $12 million that you can get from the remaining value of the equipment, which you need to discount it for in the year 4. Because you need to consider that this $12 million you're getting in the year 4. So you need to discount it based on the year 4. So you cannot say like, I paid $50 million, I get $12 million back. It's not the same because you're paying the $50 million now and you get $12 million 4 years from now. So the $12 million need to be discounted, as you can see in this equation. So if you do all the calculation, you realize that your discounted cash flow is going to be something around $53 million. And because it's higher than your initial investment, which was $50 million, which means that this project is profitable. How much? Then you need to calculate the net present value. So net present value is your discounted cash flow minus your initial investment, and he gets the net present value for this project. Okay, so there is another tool in order to compare different projects in terms of the profitability, and it is the internal rate of return. Let's have a look.
IRR, or internal rate of return, in 3 minutes. Imagine you found a wizard with a boat on a magic river. For every $100 you gave the wizard, he would give you back $10 per year, forever and ever. So how much percent do you get every year? You get 10%, because $10 is 10% of $100. Guess what? This 10% is called your rate of return. Careful, this is not yet your internal rate of return. So this 10% rate of return tells you how quickly you get back your money in exactly 1 year, compared to your original $100. It was very easy to find the rate of return of 10%. Now what if it wasn't that simple? What if the wizard brought you back a different amount every year? On some lucky years, he might bring back $70. On other years, he might bring back only $5. And what if it was not forever? What if it was for exactly 7 years? What is your rate of return percentage now? Not so easy to know now, right? It's like the rate of return is now hidden. This hidden rate of return is now called the internal rate of return, or simply IRR. To find the exact percentage, we use the IRR formula. Don't panic. I promise it's much easier than it looks. Anyway, so if you know your business's IRR, how do you use it? The simplest example is this. Let's say you borrowed money to buy a candy machine for business. When you compare the money you earned from the candy machine with the amount you paid for the candy machine, you can compute the candy machine's IRR. And when you know your candy machine's IRR, you can then compare it to your borrowing costs. If your business borrows money from the bank at a 4% interest rate and your internal rate of return is 10%, then you win 6%, because 10% minus 4% is 6%. On the other hand, if your business borrows money at a 4% interest rate, but your candy machine's IRR is only 3%, then you lose. See? It's a very simple concept. Would you like to learn how to calculate IRR the easy way and also learn even more about how to use it?
Okay, so the internal rate of return is a discount rate that makes the net present value of all cash flows from a particular project equal to 0. So the way that you want to calculate it is that before that we discussed that how you can calculate how much is going to your discount rate and compare it to the current market and then use a discount rate. The other way that you can do is just to see that at which discount rate your project is going to be profitable, which means, or in another term, your net present value is going to be positive. And then you do the calculation of the net present value, which is based on the discounted cash flow at different discount rates. And then you see that, for example, if you got 0 discount rate, which is almost impossible, your net present value is going to be, for example, 400. If you got 20%, your net present value is going to be something around $150. And at 40%, your net present value is going to be 0, which means that if your discount rate is going to be higher than 40%, which is going to be not common, then definitely you're going to lose money by doing this project. So it's not a good option. So you're in this project, you're looking at your internal rate of return is going to be this 40%. So any discount rates below that this internal rate of return, which is 40%, then it means that your project is going to be profitable. So how do you calculate it? So again, you use the same equation for net present value, and you calculate the cash flow, you discount it over the study period minus the initial investment, and you get net present value for different rates, the different discount rate that you choose. So there is no exact formula that you can get the internal rate of return. So you just need to use it through try and error, or use graph, or using a software program to calculate IRR. But as I showed you in this figure, just need to calculate the net present value at different discount rates. And when you see the transition from positive to negative, then you can narrow down your range in order to get the exact number for IRR for discount rate, which the net present value is going to be 0, and that is giving you your internal rate of return. So the higher IRR, it means that it's the more desirable investment option, because let's say that you got 5% internal rate of return. So it means that your discount rate, in order for your project to be profitable, needs to be less than 5%. So maybe you cannot find many projects with a discount rate less than 5%. But let's say your internal rate of return is 40%. So 40%, which means that even like having a 20% discount rate, still your project is going to be profitable. Maybe not as 5% discount rate, but it means that still it's going to be profitable. But if your internal rate of return is 5% and your discount rate for this project is going to be 20%, then definitely you're going to lose some money. So IRR is sometimes referred to as the economic rate of return, or also discounted cash flow rate of return. So these are other name for internal rate of return that other people refers to. Okay, so before moving on to weighted average cost of capital, let's get some break, and you'll start at 2:15 Sydney time. Okay, let's continue. The other thing that's we need to consider is the weighted average cost of capital. So sometimes you don't have all the money that you want to invest in your bank account. So let's say that you want to invest $50 million, but in a like one scenario, you may all have the $50 million in your bank account, and then you can just in cash, so you can use it for investments. But sometimes you just need to borrow money in order to do the project or run business, etc. And when you have this option, then you need to calculate not only your earnings, cash flow, etc., but also you need to see that how much is going to be the average cost of capital for the money that you're going to invest in this project. So weighted average cost of capital is determined by the cost of obtaining the funds needed to pay for a project. So project funds can be raised via additional debt. So you can get like a bank loan, or can be increasing equity capital or using a retained earning. So equity capital can be from public if you're a public company and you got shares that can be traded, or you can use the retained earnings. So as again, it's just cash in your bank account, so you can use it. So return earning or cash is going to be having no cost for you to use it, because you don't need to borrow, you don't need to pay any interest or anything on that. So it's have the zero cost for you. But if you get a loan, you need to pay interest rate, and also if you want to capital raising from public or from institutional bank, you also need to pay some cost for doing it. So those things, when you want to raise some money for a project, you need to consider in terms of the cost that you're paying for that. So each source of funds has a different cost. For example, interest rates on a bank loan. So interest rates can be like a fixed interest during the period that you're doing the project, or can be variable rate. And for each scenario, it may have different situations. So in a fixed interest rate, you can definitely say that, this is interest I'm going to pay during this period, and you can calculate your weighted average cost of capital, and with more certainty, and that's how much is going to be your profit or loss based on doing this project. But if you get a variable loan, it can depends on different things. For example, the inflation, or if the cash rate can be changed by the central bank, or the other things that's civil unrest or any other things that can affect your variable loan. Okay, so the weighted average cost of capital is calculated by multiplying the proportions of debt and equity by their respective costs, so you can arrive at a weighted average. So there are two terms. If you can just get a bank loan, then perhaps you don't need to do this. So you can the cost of your capital is just based on the paying the interest rate, and the rate that you're paying the interest is going to be the cost of your capital. But if you're doing a combination of the interest rate and also raising capital, then the costs can be different, and the way that you calculate it, you're using this equation. So let me break it down for you. So let's say that you want to spend $1 million. So your total capital is $1 million. And you want to raise 50% of that using a bank loan, and another 50% for capital raising using the equity. So then 50% is going to be $500,000 or $500,000 for debts and $500,000 for equity. So now we understand these terms for each part of this calculation. Okay. The other thing is about the cost of doing raising the money from each of those things. So in case of debt, it's going to be the interest rate that you're paying. So if it's a fixed interest rate, so it's going to be the same each year. If it's a variable interest rate, you need to put different rates based on your forecast in the future. It may change in the future. Then you need to recalculate it again. So this is the way that you calculate the cost of getting a loan. And this is going to be one part of your weighted average cost of capital. The other way is that by equity raising, so selling shares or notes. There are different things. We don't want to get into the details of that. It's going probably another course for just discussing about these things, but there are different ways of raising capital. But one thing is that normally the cost that you're paying is going to be higher than bank loan, but also depends on different scenarios. It can be lower in different environments. So this, and also the risk that you're taking, etc., and also how much is your company is kind of perceived into the market. So, and based off that, you also the people that you're buying those shares or notes, etc., because they're putting their money, and it's high risk compared to like putting the money in the bank. They expect higher return, so the cost of equity is going to be higher in that case as well. So anyway, if you also want to do the combination of these two things for your project, then you need to calculate how much is the cost is going to be for each of those, and based on the portion of the total capital, you find out that for example, if your cost of debt is going to be lower, you probably, if it's allowed, you want to get more loan. But if your cost of equity is lower than getting a bank loan, you probably want to get higher percentage of total capital from the raising equity. It's not going to be as simple as that. There are many, many other things that can affect that. This is just a very basic thing that I'm talking to you at the moment. But if you want to read more into that, you can find extra resources online. If you're interested, let me know. I can introduce you some resources too. Okay, so based on the thing that we discussed about weighted average cost of capital and internal rate of return, which one is not a profitable project? So we got three scenarios. Weighted average cost of capital equals to internal rate of return. Weighted average cost of capital is higher than internal rate of return, or WACC is going to be lower than IRR. Okay, so I think that's in the video also showed that internal rate of return is at the rate that your project is going to be profitable, so the discount rate. So let's say that you get a loan from the bank in order to fund this project, and then the interest rate on that loan is 5%. Okay. So let's say that you don't want to raise any equity or something, so just getting the loan from the bank and you're paying 5%. So your weighted average cost of capital is going to be 5%. And then you do the calculation of the IRR, internal rate of return, and you realize that the discount rate that your project is going to be profitable, or IRR, is going to be 5% as well. So WACC, or interest rate that you're paying for the bank loan, is 5%, and internal rate of return is also 5%. Okay. In this scenario, what do you think? Or if there is the loan that you're paying the interest is going to be higher than your internal rate of return. Yep, no profit, no loss. So we want to have the weighted average cost of capital be lower than internal rate of return. Okay, so we want to pay lower interest rates and have higher internal rate of return. So for some reason, you put it otherwise. Maybe I didn't explain it at that time very good. So yep, I hope that is clear for you now. So weighted average cost of capital is the money that you pay to borrow money. Let's say that you got the cash, all the money that you want to invest as a cash, then your weighted average cost of capital is 0. Okay, so it's the most preferable option for you. So any internal rate of return higher than that is going to be good and is going to be profitable. Considering that it's going to be higher than the discount rate, the market discount rate. But on the other hand, internal rate of return, you want to, as we mentioned, we want to have the highest internal rate of return. So you want to minimize weighted average cost of capital and maximize your internal rate of return. So this is going to be the best scenario for the profitability of the project. Okay, any question? Yes, so we want to have weighted average cost of capital considerably lower than internal rate of return in order for a project to be profitable. Because otherwise, if we pay too much interest rates on the loan that you're getting and we are not getting back that, so it means that the bank is going to be profitable because they're getting the interest, but we are not generating that much of return in order to pay the bank. So we are actually losing our money and paying the bank. Again, so let's clear that for those of you just see the recording. So weighted average cost of the capital should be lower than internal rate of return. On the contrary, that's what your flow students put it here on the slide. Okay, so let's move on. Yep, sorry. Yeah, you're right. You said that which one is not profitable. Sorry. That means that, yeah, that's correct. Then the weighted average cost of capital should be higher than IRR. I just get confused. So yeah, that's right. So the weighted average cost of capital should be higher than IRR for the project to be not profitable. So if the weighted average cost of capital equals IRR, then it's no loss, no profit. But if it's the weighted average cost of capital is below the internal rate of return, then the project is going to be profitable. Okay, so let's move on. Payback period.
Payback period is the time it takes for an investment to generate an amount of income or cash equal to the cost of the investment. The shorter the payback period, the better the investment is judged to be. Managers and investors use payback period to make quick judgments about a particular investment or capital purchase. The payback period equals cost of investment divided by annual cash flows. The main drawback of payback period analysis is that it does not take into account the time value of money. A dollar today is worth more than a dollar in the future. Payback period also does not take into account what happens after payback, and thus ignores the overall profitability of the investment. These two limitations of payback period analysis are why most managers and investors feel net present value (NPV) is a superior tool for making an investment decision. Sonny owns a golf cart manufacturing business in Texas. Sonny's business uses a lot of electricity and the monthly electric bill is very high. He wants to reduce his bill and is thinking of installing solar panels on the roof of his manufacturing building. It will cost $90,000 to buy and install solar panels. With the panels installed, Sonny estimates his electric bill will have a savings of $24,000. Dividing the total cost of the solar panels, $90,000, by the annual cash flow, $24,000, the payback period is 3.75 years. So in 3 years and 9 months, Sonny will not only reduce his carbon footprint, but also start seeing the benefit of his investment on his electric bill.
Okay, the payback period probably is the most simplest things and probably the most inaccurate things in order for to see the project, because it doesn't put into account the present value of money. So the way that it's calculated is pretty simple. So you got the cost of investment and you get the annual cash flow generated from this investment, and you divide those two, and that gives you your payback period. And you want to have a short payback period, which means that a more attractive investment. So let's say that you want to install solar panels which cost $5,000, and savings from the electricity bills are $100 each month. So if you want to calculate the payback period, so you just put the $5,000 here as your investment, and you got 12 months in a year, and you got savings of $100 per month. So, and you can see that it's the payback period is going to be as I mentioned, it's not going to consider the net present value of money, and also so the better way of doing that is going to be using another version, which is the discounted payback period. So discounted payback period calculated the number of years it takes to break even from undertaking the initial expenditure by recognizing the time value of money, which means that the discounted payback period actually using the discounted cash flow. So how to calculate? In order to calculate a DPP, you need to calculate net present value for each period. So normally it's each year. And then plot the NPV versus time, which can be year if your each period is year. And then the break-even point, which the net present value is 0, is going to be your discounted payback period. So you've done the same thing for internal rate of return. The difference is that for internal rate of return, you just draw the graph, which is going to be net present value versus different discount rates. But for the discounted payback period, you're going to draw the net present value versus time. So that gives you the discounted payback period. So let's have a look. So this is a example of a project. So you can two phases of the project execution and project result and use. You got from the start of the project, you do not earn anything. You just paying the cost of the materials and labor. So your cash flow is going to be negative, and it stay negative because you stay paying for the materials and labor, etc. Until the project is completed. So let's say that you're constructing building, so you finish it here. So when the project is completed, until then you got the only negative cash flow because it's only cash outflow. After that, your cash flow is becoming positive, which means that your discounted cash flow is getting higher and higher, and it goes into the positive territory. So as long as your net present value, which is the discounted cash flow minus your initial investment, equals to 0, then this is going to be your discounted payback period. And after that period, your net present value is going to be positive. So which means that you need to wait equal to amount of the discounted payback period in order to generate any profit. So why you want to do it as a investment? Because let's say as a company, you invest in something and you want to get your money back in order to invest in something else. So if your discounted payback period, it takes too long, let's say it takes 20 years for your to be positive and you get all the investment money that you put in the first place, which means that you get some limitation in order to invest in other projects. So, and because of that, the discounted payback period is important for you to realize when you're comparing different projects for the project selection. So the lower discounted payback period is going to be more preferred. So let's do an example. Let's say that you want to install solar panels which cost $5,000 and the saving from the electricity bills are $100 each month. But in this example, compared to the other example, we put a discount rate of 10%. So let's say that in which year the discounted payback period happens. So first of all, you got all the years. Let's assume that we put for 10 years, and you can do this calculation on Excel. It's going to be much straightforward than doing it manually. So in the year 0, which is just the start of the project, you are not saving any money from electricity bills, and you just pay for the solar panels, which is $5,000. But in the first year, you can see that you're generating some money or savings from the electricity bill, which also discounted for the first year. And then, but your net present value is still negative because you need to deduct discounted cash flow, this value, minus the investment, which is 5,000. So you're still in the negative territory. So in the year 2, you also you get some cash flow from the saving as well. You did the treatments for the discounted. As you can see, it's going to be lower than the first year, but in total, your net present value is going to be less negative because you're generating more money, and this is accumulative of the discounted cash flow that you earned up to second year. And you do it until you can see in this 6th year, you're getting positive. So your net present value is getting positive. So your discounted payback period is going to be something between 5 and 6 years. The easiest way to do it is just plot the graph, and you can just see that at which time you're getting the net present value of 0, and this is going to be your discounted payback period. Or you can just use increments here from 5 to 6 year, maybe 5.1, 5.2, and do the calculation and see that's what exactly which year is giving you the net present value of 0, and that is going to be your discounted payback period. Okay, I hope it's clear. If you have any question, please let me know, and if you want me to explain it again. Yeah, no, it's not linear. So you just need to use it from the curve and see at which point the curve is crossing the net present value of 0. So because the calculation is not linear, so you can not just do the linear. So either you need to try an error between 5 and 6, put some numbers with the increments like 0.1, 0.2, and just see that at which discount rates at which year the net present value is going to be 0, or the other way, just using the graph and see that which point is going to cross the line. Okay, so in the previous example, if discount rates increase to 20%, will discounted payback period increase or decrease? Okay, almost 60% saying decrease. Is there anyone wants to say that why you think that's by increasing the discount rates, the DPP or discounted payback period is going to decrease? Any reason behind that? So the money loses more value, which means that your discounted cash flow is going to be less. So why discounted payback period also decrease? So yep, that's right. So DPP is going to increase. So for those of you that saying that it's going to decrease, what's your point of view? Any answer? Nope. Okay, the correct answer is that when you increase the discount rates, which means that your discounted cash flow is going to be less. So net present value of money is going to be less. So it takes more time in order for you to get to the break-even point, which your net present value go to the positive territory. And because of that, your discounted payback period is going to increase. Yep, that's right. Okay. If it's still not clear for you, the thing that we discussed, let me know. I'll explain it. So there are some databases that you can use for the life cycle costs in terms of the different material, etc. So if you want to use the cost for each of those things, so you can use these databases. And also there are some publications for the costs that you can use. You can use academic journal papers, or if you're working in construction, so you can use the construction cost guide, Rawlinson's, and also building cost guides that I put the references for you here. Okay, so this is the end of this lecture. If you have any questions about this lecture, or if you have any question in general, please feel free to ask here or put it on a Slido. More than happy to answer your question here. Okay, if there's not any questions, so all the best with the quiz tomorrow. So the quizzes will be at 6 p.m. tomorrow. Don't forget, and all the instructions are available on Moodle. You can have a look at Moodle. So in terms of the time and everything, so it's similar to the quiz one, but the time is a little bit more. Is there any calculation question for tomorrow quiz? Yes, possibly. For the whole project management, which part do we prefer? The architectural part is still in the earliest stage. I cannot say how many calculation because for each person might be different. So it's a kind of randomized question. You may have a calculator, but you may not necessarily need to use it. But in case if you want to accelerate your calculation, then you can also use a calculator. So anyway, you're in front of computer, so you can do all the calculation just using the computer calculator or using your mobile phone. So Harry, I didn't get your question. If you can turn on your microphone and explain. Yeah, the time is enough. So I'm not asking you to do like a lots of calculation for 20 minutes quiz.
Can you hear me?
Yes.
My question is the whole project management is like a whole big part. So which part that we will be more focused, like the early stage, like the calculate the money, or the in the middle of the stage, we control the whole process, whole construction, whole construction process. So that's the questions I want to ask.
Yeah, I think it's thanks for your question. It really depends on the work that you're involved in. Some project manager is just a small part of the project with a little bit of planning, but some other projects is involved from the beginning in terms of the different project, in terms of the project selections, doing all the calculation in terms of the which project they want to do, etc. So it depends on at which level of project management you want to do the job. As a junior project manager, perhaps you won't be involved in the project selection part. Would be starting with some doing some little bit of planning and monitoring and considering the Gantt chart, etc. But as the senior project manager in a big companies, you also involved in the project selections, and you can give feedback, etc. in terms of getting the economical value and rate of return for different projects.
Okay, thank you.
No problem.
Thank you.
Can you show the calculation process of DCF for the last activity? Sure. So you mean for the discounted payback period? Okay. This one? So the calculation process for discounted cash flow, we already showed it's similar what you've done here. Okay. So you just use the cash flow for each year, you use the discount rates, number of the year, and use it for, this is for year one. and this is for year 2 and for year 3. And when you're using the net present value for each year, so for net present value for the first year, you're going to just use the discounted cash flow for the first year minus the net present, minus the initial investment, and that gives you the net present value for the first year. For the second year, use the sum of the discounted cash flow for the first year and the second year minus the initial investment, and that gives you the net present value for the second year, and the same for the third year, fourth year, etc. So all the calculations and different examples will be provided on tomorrow's and also Friday's workshops, and all the Excel file and everything will be provided to you after the workshops. So then you can go through all the calculations if it's still not clear to you now. Okay, any other questions? If not, then thank you very much. All the best with your quiz tomorrow, and I'll see you for the last lecture next week. Okay, which one do you want me to show you? Because you got already the cash flow here. So this is the formula that you use for each year. And so for the first year, you're going to use your earning, your saving, and then you're going to discount it for the first year. And for the net present value, you're going to deduct the initial investment from the first year cash flow. And for the second year, you're calculating the cash flow based on your savings, and you discount it. And for the net present value for the second year, you're going to have a sum of the first year and second year cash flow minus the initial investment, and that gives you the net present value for the first 2 years, and you do it for the third year, fourth year, etc. And then you get the net present value until it gets into the positive territory. That's the way that you calculate. As I mentioned, all the Excel files and everything, a bit more example will be provided during the workshop, so you can go through more example and see that how the calculation has been done in the Excel files. Okay, great. Thank you all. Have a good rest of the day. I'll see you next week.